Let's now move on to the logarithmic functions, how we handle that with calculus. So first of all, differentiating. Turns out that when you differentiate a natural log, I'm using log. As I said the other day, I probably should be using ln, makes it a lot clearer that we're talking about natural log. But when you're differentiating a natural log, what you're actually doing is you're differentiating the function. So it's a log of a function. So you're differentiating that. You put that on the top of a fraction, and then on the bottom of the fraction goes the actual function itself. So it's derivative on function. If it's not a natural log, so some other base, we saw with exponentials that we'd do it exactly the same, but we would multiply by the natural log of the base. But logarithms are the inverse of exponentials. So when we differentiate, we'll divide by the natural log of the base. So again, it's not exactly the same, but we need to put the natural log of the base on the bottom of the fraction. So we get something like this, log of 3x plus 5. So it's derivative on the function itself. Differentiate 3x plus 5, you get 3 over 3x plus 5. Log of x cubed, derivative, 3x squared on x cubed, 3 on x. Of course, you can use the log laws to help you out, because you could have done it this way. Oh, hang on, that power I could bring to the front. So I could rewrite the function as 3 log x. Differentiate log x, I'm just going to get 1 over x. And so it's 3 times that, 3 over x, same answer. Oh, here's a good one. Log, the log of log x. So the function that we're logging is log x. So it's the derivative of log x that will go on the top of the fraction. And of course now we're differentiating a log function. So on the top of the fraction goes 1 over x over the function itself, log x. And we don't leave fractions like that. So the x moves down the bottom and we get 1 over x log x. Log of x plus 3 times x plus 2. Okay, the derivative goes on the top, but the derivative, I suppose I could have expanded it out, but I'm using the product rule. Write down the first diff the second, plus write down the second diff the first, over the original function itself, tidy up the top, and we have our answer. Again, we could use log laws to make life easier. So I could break that up into 2 different log functions. The log of x plus 3 plus the log of x plus 2. They're both very easy ones to work out, because differentiate, you just get 1 over x plus 3 plus 1 over x plus 2. I mean, that is an answer for the derivative. If we combine it all into one fraction, well then of course we end up with the same answer. So depending on what you're doing with the derivative, you might leave it at the first line there. If you're finding stationary points, you probably need to go all the way, because you'd be saying equals 0. So you'd need it all as one fraction. Oh, here we go. Derivative on function. We've got to use the quotient rule. So on the top of the fraction, square the bottom, write down the bottom, diff the top, minus write down the top, diff the bottom, over the original function itself. So playing around with that. The fraction that's on the top of the fraction becomes minus 3 on x plus 2 squared. Invert and multiply by the fraction that's on the bottom of the fraction. X plus 2 and x plus 5. The x plus 2's cancel. We get our answer. This is one where definitely the log laws is going to make life a lot easier, because we can turn that into a subtraction. Each one of those is very easy to do. And then playing with algebraic fractions, we get the answer. So if you can, I mean, use your log laws to your advantage, if it's going to save you time. I mean, sometimes it doesn't, sometimes it does. Here's one where the base is not e. So what did we say? We said do it the same as normal, but also divide by the natural log of the base. So we have 6 over 6x, but also log 10 on the bottom. 6 of course cancels with the 6x, there we go. 1 over x log 10. And that will do us for today.